So on number 56, with these word problems, the nice thing is I'm not making you derive the quadratics. Okay, so I'm giving you a quadratic equation in some form. And so you want to recognize what form you have and what are the benefits of that form. So in this one, without even reading the problem, we got our equation here. And we can quickly, from this equation, get a few things. What form is this? Factored form. Okay. And from this form, what can you tell about the graph? X-intercepts. So if it's already factored, we can quickly get them. We could set x minus 6 equal to 0 and get x equals 6. We could set x minus 22 equal to 0 and get x equals 22. And so we get our x-intercepts right away. And if all these problems, it's nice to have just a little sketch of what's going on. And so it doesn't have to be perfect. Let's say this is 6, this is 22. Is this parabola going to open up or down? And there's an easy way to tell. You look at the leading coefficient, which we call A. If A is negative, it's going to open down. If A is positive, it's going to open up. So we know that this parabola looks something like that. Okay, and so the vertex is what we call, because it's the highest point of the graph, and so we call it a what? Maximum. If the vertex is the lowest point, we call it a minimum. And if you're working with a word problem, you're either the problem's either going to ask you for the vertex or the x-intercepts. That's it. Okay, and we already have our x-intercepts. We don't have our vertex, but we can easily get to it, and we may need to. But before we do, let's look at what else is here. So we want to, all that reading, what you want to get out of all that reading is kind of the context of the problem. So what is, this is not just x and y, what do they represent? And so if you read through this problem, you end up getting that y is the profit that this company accumulates, and x is how many units that they produce in a given day. Okay, so 6 right here, if this x-intercept means if they produce 6 of the units, they get 0 profit, right? If they produce 5 units, what's going to happen? They have a loss, right? So in this problem, it does make sense to have negative y values because you can lose money, right? And so just thinking, that's going to help you when we talk about our domain or our range. What kind of values can we have? Can x ever be negative, really? No, because we can't produce a negative number of units. But the money can be negative because that means that represents a loss, not a gain, right? Okay. If you look at B, we see the word maximize, and C also has the word maximum. And so B and C are indicating to us that we need to find the vertex. If we find the vertex, we'll be able to answer B and C. And if you have 2 x-intercepts, a good way to find the x-intercept is to first find the axis of symmetry, which is in the middle. And how do you find the middle of 2 numbers? Average them. So add 6 and 22 and divide by 2, which is 28 over 2, which is 14. So the middle is going to be 14. And 14 is going to be one of our answers. It's the answer to which question? B. How many units need to be produced each day to maximize the profit? 14 units. C says, what is the maximum daily profit? Well, we need to find the y value to do that. If we have the x value, we can get the y value. What do we need to do? Do I have to change it to standard form first? No. You can use the form you have, and it's easier to use the form you have. So we got y equals negative, plug in 14 for x minus 6 times 14 minus 22. So I'm plugging in 14 for x here, and I get y is negative 14 minus 6 is 8, and 14 minus 22 is negative 8. So we end up with y is positive 64. Okay. So 64 represents some kind of profit, and it may mean $64,000. It may be $64 million. I don't know what the units are because the problem didn't state what the units of y were. Does it? It just says it's profit. So all we can really do for C is say y equals 64 units. I can't say dollars or thousands of dollars because the problem doesn't tell me. What are the domain and range of this function? Well, the domain for sure has a minimum, right? You can't say all real numbers because it doesn't make sense to produce a negative amount of units. But is there a maximum? What would the maximum be? Like, can I produce 23? I can. What happens when I produce 23? I start losing. Can I produce 25? Sure. So there really is not a cap for the maximum, but there is a cap for the minimum. And so for our domain, we're going to say, you know, our x value is going to be less than or greater than or equal to 0, or 0 is less than or equal to x. And we're not going to put a restraint for the max on that one. For the range, we definitely have a cap for the maximum. It's not going to go above what value? Not going to go above 64 units. Is there a cap for the minimum? No, you could keep producing like 100 units in that day and really lose a lot of money, right? So there's no cap for the min, but there is a cap for the max. So we're going to say y has got to be less than or equal to 64. Okay. Question on 56. Okay. Now on to 57. 57's given us an equation. It's quadratic. It's in which form? Standard form. Okay. And you read about the problem. It's about a baseball being thrown into the air. It's got height and in feet, and t represents seconds. So we know the units of this function. And as you read through what we need to find, we see the word maximum and maximum again. And maximum indicates what? We need to find the vertex. Okay. Does this parabola open up or down? Down, and it better because we know we're talking about a ball flying through the air, right? We got something like this. And we're after the maximum or the vertex. Now, if you have standard form, there's options for getting a vertex. And let me just state them here. So if you have standard form, what's one way to get a vertex from standard form? There's different routes you can take. Just what's one route you've done in the past? Factor. So we could factor and then find x-intercepts. And then from the x-intercepts, you find the line of symmetry. And then you get the vertex. That's one route you can take to the vertex, right? What's another route you can take to the vertex from standard form? Yeah. You can complete the square to get vertex form, and you write to the vertex. There's a third way. Anybody know the third way? What's that? What do you mean quadratic formula? How would you use it? How do you find what x equals? Oh, like the x-intercepts? So you could use the quadratic formula to find the x-intercepts and go from there. But there's a quicker way that, and it's related to the quadratic formula. You get the axis of symmetry from the formula what? X equals just negative b over 2a. If you have the square root part, that finds the x-intercepts. But if you want to find in between, you throw out that square root part. This finds the middle. And then you can plug that in to the equation to get the vertex. And this is the route we're going to take with this problem because the problem we're looking at does not factor, so we can't take the first route. Completing the square you could do, and I saw some of you do it, but it's ugly. And hey, it's a great practice if you want to. No problem about that. But hey, we can jump right to the middle here. This middle, x equals negative b over 2a, which is negative 30 over 2 times negative 16. And that's going to end up being positive 30 over 32, or positive 15 over 16. So right away, we know the middle, 15 over 16. Okay, and that's the answer to what question? A. So A is 15 over 16 seconds. And then what's the ball's maximum height? Well, we can get that by plugging our fraction into the equation. And that's going to be a little fraction work, but we can do it. So that's negative 16 times 15 over 16 squared plus 30 times 15 over 16 plus 6. And negative 16 over 1 times 15 squared is 225. 16 squared is 16 times 16, and I'm going to leave it that way because I'm going to reduce. Okay. Plus, I'm going to reduce some more. 30, I'm going to make a 15. 16, I'm going to make it 8. So we get 15 times 15, 225 for 8 plus 6. So now we have negative 225 over 16, positive 225 over 8, and 6 over 1. And we need a common denominator to add fractions. So the second fraction I'm going to multiply by 2 over 2. The last fraction I'm going to multiply by 16 over 16. And I get negative 225 over 16 plus 450 over 16 plus 6 times 16 is 60 plus 36, so 96 over 16. If I add the first two, I get 225 over 16. And 225 plus 96 is 321 over 16. So yes, it's a little bit of work with the fractions. Okay. We got the x value really quickly. The y value we had to work for, okay? And so we found the ball's maximum height is 321 over 16 feet. Okay. What's the range of this function? So does it minimize? Is there a minimum? It's not going to go below the ground, right? So ground level is height 0, right? So 0 less than or equal to the height less than or equal to, does it have a max? Max is out at what? 321 over 16. Okay, so this was a vertex problem. And again, remember those 3 routes you can take to get to that vertex. Okay. Question on 57. Okay, last one, 58. 58, you have this ad that you're going to put a photo in. Photo is 7 by 5. And so the area of the photo is what? 7 times 5. So it's 35 unit or inches squared. And then it says the ad is double that area. So the area of the ad is going to be what? 70. Okay. And we want to solve for x. Now, if you look at this ad, the base is the photo length plus x. So I'm going to write that as x plus 7. And the height here is the height of the photo plus x again, so we got x plus 5. And so another way to represent that area is to write x plus 7 times x plus 5. And now we can set those equal to each other to have an equation in which we can solve for x. So that's your starting point. And a lot of you started there. And then the rest of it is solving for x. And we have different methods that we work from. But the most important thing is before you even use one of those methods, you want to make sure it's equal to 0, and you want to make sure it's not factored and equal to something else. So you're going to have to multiply this out and to expand it and make this thing equal to 0. So we get x squared plus 5x plus 7x plus 35 is equal to 70. If I add this 5x and 7x, I get x squared plus 12x. And then I'm going to subtract 70 from both sides to make that equal to 0, and I get minus 35 equals 0. So this is where we're going to start thinking about our methods. Okay, and we have factoring, quadratic formula, or completing the square. So factoring is where you want to start first. Can we come up with two numbers that multiply to negative 35 and add to 12? What are they? So you want your product to equal negative 35, and you want the sum to equal 12. Give me two numbers that would work. Here's, 5 and 7? So 5 times 7 is not negative 35. Almost works, but you try and this thing doesn't work. So it doesn't factor. So then we say, okay, we got to either use a quadratic formula or complete the square. Both work. Now quadratic formula is good and it works, but you got to be careful when your numbers start to get big. And this is not too big, but if I had like a 9 in front of the x squared, we're working with a 35 and a 12, things can go, it can be a little difficult. This one, it's pretty set up for completing the square because there's a 1 already in front of x squared. 12 is an even number, easy to take half of that and square it. So I'm going to go the completing the square route. But you could also choose the quadratic formula. So when you're completing the square, the x squared plus 12x is the piece you really need for the completing the square part. The minus 35, I'm going to move that back over to the right-hand side. We don't need that part right now. So then you start the process of completing that square. And the process is you make sure a is 1. If it wasn't, you'd put parentheses around here and factor out whatever a is. Okay, but it is 1. Then after that, then you would find b over 2 squared. In this case, 12 is b, so 12 divided by 2 squared is going to give us what? 36. And so I add 36 to both sides. And when you add that to the left side, this thing's going to factor perfectly for us into a perfect square. And it will always, I mean, you can go through the steps of factoring, but just to know, it will always factor to x plus b over 2 squared. And so b is positive 12, so we get x plus 6 squared is equal to 71. To solve now, take the square root of both sides, and you get x plus 6 is positive or negative square root of 71. And then subtract 6 from both sides. You get x is equal to negative 6 plus or minus the square root of 71. Okay, so now we got two values for x, and it's important to know that we have two values. One is negative 6 plus the square root of 71, and the other one is negative 6 minus the square root of 71. And here's where you want to think about what does x represent? What's our context here? And x represents the distance between our photo and the edge of the paper, or the edge of the ad, right? So I got to throw this one out, because a negative plus a negative is negative, and you know a distance is not going to be negative. And then we need to think about this. Is this going to be negative? Is negative 6 plus the square root of 71 positive or negative? So square root of 71 is between what two integers? 8 and 9. Because square root of 64 is 8. Square root of 81 is 9. So this is between 8 and 9. So it's 8 point something. So we got negative 6 plus 8 point something. So that's going to be positive. And so this is exactly what x is equal to. Okay. So it's not a guess and check problem. You're never going to probably guess that number, right? You have to actually solve to get that number.